Okay, so this is part one of identifying and graphing conic sections. And what you can see here is that we're going to first be talking about the standard form of equations of translated conics. So that's important. We're talking about translated conics. Conics where point HK is either the vertex if it's a parabola, okay, or the center if it's any other conic. Okay, so in a parabola, h comma k is the vertex. So hk is the vertex. Okay, and that goes for vertical axis parabolas as well. And in circles, h comma k is the new center. Okay, and the h comma k being the center goes for ellipses, both vertical and horizontal, and hyperbolas. And again, that's both horizontal axis hyperbolas and vertical axis hyperbolas. Okay, so what this has the effect of doing is expanding our original standard forms of these equations, where h comma k was always 0 comma 0, and allows us to adjust for any translation that may have taken place. Okay, so if it's been translated to the left, to the right, up, or down. All right. The nice thing is that it's very intuitive. H goes with the x always, okay, which means that we're going to have a horizontal translation. If there is an h value of something other than 0, it will be translated either to the left or to the right. Okay, and k always goes with the y term, which means that it will be translated either up or down if it's something other than 0. Okay, so h translates left or right, and k translates up or down. Okay, probably the easiest way to do this is to jump in. So we're going to first go to an example. So I will change slides and we will do the first example. Okay, so now right back to it. Example 1, identifying and graphing identifying and graphing conic sections. So we've got example 1, writing an equation of a translated parabola. So in this one they're going to give us some information and we're actually going to write the equation. Okay, they've already told us that it's a parabola, so it was very nice of them. We probably could have figured that out based on looking at the equation, but we're going to do what we have and then go from there. So it says write an equation of a parabola whose vertex is at 1 comma negative 3 and whose focus is at 1 comma negative 4. Okay, so we're going to take a look first at the vertex. So it says that the vertex is at 1 comma negative 3, and remember that our standard form of a parabola, okay, is either x minus h squared equals 4p times the quantity y minus k, or y minus k squared equals 4p times the quantity x minus h. And it all depends on which direction the parabola is opening. So in this particular case, we have a vertex at 1 comma negative 3, so I'm going to do a quick, very small sketch here. We have our standard coordinate plane, x and y axis. We have a vertex at 1 comma negative 3. Okay, so we have a vertex somewhere in there. Okay, and a focus at 1 comma negative 4, which means that it's 1 lower. Okay, well what that tells us is that because the focus must be inside the parabola, we've got a parabola that opens down. Okay, so because the parabola opens down, it has the form x minus h squared equals 4p times the quantity y minus k, where p is, well, is it less than 0 or is it greater than 0? Because it faces down and not up, it's less than 0. So that means that we know that P is going to be negative. Okay, P is definitely going to be negative. So we know that. The vertex is at 1, negative 3. Okay, and we said that our vertex always has the form h, k. So that means h is 1 and k is negative 3. So 1 and negative 3. The distance between the vertex 1, negative 3 and the focus 1, negative 4 is the absolute value of P is equal to, and of course that's going to be our standard distance formula, so that would be x2 minus x1, which is 1 minus 1 squared, plus the quantity y2 minus y1, which would be negative 4 minus negative 3 squared. Okay, so 1 minus 1 is 0, 0 squared is 0, so that just goes away. Negative 4 minus negative 3, well that's the same as saying negative 4 plus 3, which is negative 1. Negative 1 squared is just 1, and the square root of 1 is 1. So P is equal to 1 or negative 1. But because we know that P is less than 0, P must be equal to negative 1. So now all we have to do is plug all of this information into our original standard equation. So we take our 1 and we plug it in for h. We take our negative 3 and we plug that in for k. And we take our negative 1 and plug that in for P. Okay? And we just simplify and rewrite. So we get the quantity x minus 1, because 1 is our h, squared, equals 4 times negative 1 is negative 4 times the quantity y minus negative 3. Well, y minus negative 3 is y plus 3. And we're done.